All right, here is your algebraic solving of the early section of EOC. So for number 1, starting with what is the remainder x cubed minus 1 divided by x plus 2. I'm going to show you 2 algebraic ways to work on this one. First one is synthetic division. So I know I'm going to put a -2 up here because I always take my x plus 2, set it equal to 0 to find my actual root. And so we're going to synthetically divide -2 into our expression. For here, we're going to need a 1 for the x cubed, a 0 for the x squared that's missing, a 0 for the x that's missing, and a -1 for the -1 that's present. Bring down the first column, multiply, add, multiply, add, multiply, and then add. So this is our remainder. So our answer to this question is -9. You could also do long division, but I know most of you guys will choose synthetic. Another thing to remember that the remainder is always equal to f of whatever the x that you're checking is. So in this case, if I had plugged in f of -2, it's -2 cubed minus 1. So I'm just plugging in -2 for the same reason that I chose -2 as my divisor. Plug it in. That gives me -8 minus 1, which indeed, again, proves that my remainder is -9. So there's 2 algebraic ways to look at it. Number 2, I would do this one in Desmos, so I will do that one in the other video. Okay, for this one, it's told me I'm going to do this one algebraically and then show you how to check it in Desmos as well on the other one. I would start out with synthetically dividing my -1 out to see what is remaining when we get here. So I've got 1, -1, add, -2, that'd be -4, 4, 0. So this, again, we're not surprised that we got a 0 because it told me that it was going to be a 0. And that leaves me with x squared plus 2x minus 4. And you may ask yourself, okay, I need to solve this quadratic. Well, let's see. Can I factor it? Are there any 2 numbers that multiply to -4 and add to 2? Only numbers that multiply to -4 are -2 and 2, which don't add to 2, and -4 and 1, or 1 and or -1 and 4, and those would give me a 3x or a -3x. So it's not factorable. So the fact that it's not factorable actually just screams that these aren't even answer choices. And so we're going to be left with either C or D, and we can do it by completing the square or quadratic formula. I'm going to do completing the square because it's going to be the fastest. So set it equal to 0. I get x squared plus 2x equals 4. And remember, the thing we add to both sides is b over 2 squared. So my b is 2. So I'm going to be doing 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 to both sides. And I'm already seeing that this is going to be 4 plus 1, which is 5. This is going to be something squared. X plus 1 is what it's going to be when I factor it. And you can see this coming to fruition, that this is going to be that square root of 5 answer here. I'll finish it out, but this becomes x plus 1 equals plus or minus square root of 5. Subtract the 1, x equals -1 plus or minus square root of 5. You could also do this with quadratic formula, and you'd get the same answer. For the next one, this one asks me to divide these 2 expressions. So when I'm dividing, in this case, there's no way to go around this without using long division. So I'm going to divide x squared minus 3x minus 40 into x squared minus 2x minus 37. And when I'm thinking about this, the first, what do I multiply by this to get that? Well, I just need a 1, right? So when I multiply by 1, I'm going to get x squared minus 3x minus 40. But remember, I have to subtract that. So I'm subtracting that, right? Which really means I'm adding a negative of everything. So that would be plus, negative, plus, plus. So when I combine these, I get negative, these cancel. Negative 2x plus 3x is x. Negative 37 plus 40 is plus 3. So this would be my remainder. So we can see we've got 1 with a remainder of x plus 3. So that would be this one. I'll show you another way to do that one in Desmos as well. All right, this one. For this one, first thing we want to do is get a common denominator. So that means on the first one, I want to multiply this one by 7x minus 2 on top and bottom. And I want to multiply this one by 4x plus 3 on top and bottom. And notice that this one over here has already got that denominator. My goal really at this point is to multiply the things that I've written down and combine like terms to see what comes out with ax squared plus bx plus c. So when I multiply the first ones, these, okay, so I'm going to get 21x squared. And again, you can use your area model to help you multiply. I know it's going to be plus 10 down here. Got negative 6 and negative 12, which is negative 18x. Plus, and then I'll add over here, that'd be negative 8x squared. And then I'm going to have negative 6, positive 4, so that's negative 2x plus 3. Then I just need to combine these, and this will reveal what my A, my B, and my C are. So 21x squared minus 8 is 13x squared. Negative 18, negative 2 is negative 20x plus 13. So if I'm looking at my answer choices, we can see that I'd need to drop this. I didn't get the right middle answer. 6 and negative 35. Oh, good Lord, I got that middle part wrong. This was not negative 18. This was negative 35 minus 6, which is negative 41. And negative 41 minus 2 is negative 43. And that is indeed an answer choice. There's a way to do this one on Desmos too, where you check the left and the right are equivalent. I'll show you that in the other video. Okay, this one, let's talk about by hand. So the first thing I'm going to do, whenever you have negative exponents, just a reminder, basic rules say that if I have x to the negative 1, that's 1 over x to the 1. Or if I had like x to the negative 3 over y to the negative 2, I would rewrite that as y to the 2 over x to the 3. So whenever I have negative exponents, I want to bring them to the top or the bottom, and based on where they are, and make their exponents positive. So first thing I'm just going to do is just make sure I have all positive by rewriting this. Okay, and I'm also just not writing the ones as an exponent there because that doesn't really, it's not necessary. Then I'm going to factor this x squared minus 5x plus 6, so that would factor to negative 2 and negative 3. So this would be x, and I'm also going to go ahead and write this out as x minus 2 times x minus 2. And this would be x minus 2 times x minus 3. And instead of division, remember we changed that to multiplication of a reciprocal. So that would be x minus 3 over x minus 2, x minus 2. And then we start seeing things cancel because we're just simplifying. So x minus 2, x minus 2, x minus 2, x minus 2, x minus 3, x minus 3. All I'm left with is an x minus 2 on the bottom, which means that D's got to be our answer. This one we could also check in Desmos by writing two equivalent expressions in y1 and y2 and checking and making sure that they graph the same thing. All right. Company makes and boxes spaghetti. One machine fills a box with approximately 32 ounces of spaghetti. After the boxes are filled, another machine weighs each box. A box is discarded if the weight of the box differs by more than 0.25 ounces from the target weight of 32 ounces, which inequality can be used to find the range of acceptable weights. So we know its absolute value because it could be the weight. So as I'm looking at this, it says the weight, and I'm spelling things wrong, that the weight, okay, can't differ. The difference of the weight has to be more than, not more than, less than or equal to the 0.25. So the difference in the weight from what it's supposed to be would be whatever the difference is between the 32 and whatever my weight I'm getting is. So that one would be C. That's just a reasoning thing, thinking about your restrictions. You can also graph this and test some X values, right? Like see if 31 ounces would work, so on and so forth. It'll graph it for you and see if it falls in the shaded region. I'll show you this one on Desmos too for funsies. I would do this on Desmos, but I'll real quick go through. We know it's been moved down to, right? Because normally our absolute value, just to show you where your parent function falls under, goes directly like this. So I know it's gone down to, so that means that would not be D or C because those would be moving to the right. And then I also know that the slope is different if you look at it, right? Like it's way more, it's in this case where the 2 is, it's showing me that it's horizontally compressed so that it looks more wider, so it's got to be B. You can also check points, right? So like if I plugged in 1 into A, so here's my A, if I plug in 1, when I plug that into that equation, absolute value of 1 is 1, 1 minus 2 is negative 1, I can clearly see that at 1, I actually have 0. So, but if I check B, and I check 1, 2 times 1 is 2, 2 minus 2 is 0. So this is a better answer because it actually matches the graph on the coordinates. So you can check it like that. You can also just graph it in those. All right, Martha can paint a room in 2 hours. Jamie can paint a room in 6 hours. How long to the nearest tenth of an hour will it take them to paint the room together? Okay, so the way to think about this is if Martha can paint a room in 2 hours, that means that Martha can paint half a room in 1 hour. And if Jamie can paint the same room in 6 hours, that means Jamie can paint 1/6 of a room in 1 hour. So together, how much can they paint in 1 hour? Well, that'd be 1/2 plus 1/6. Or if I get like common denominators, 3/6 plus 1/6, which is 4/6. So in 1 hour, they can paint 4/6 of this room, which means that if 1 hour, 2 hours is going to be too much, right? So like, or 2/3. So if they can paint 2/3 of the room in 1 hour together, okay, then they need another half hour. So 2/3 times what would give them a whole room, right? That's all you're trying to say. So that would be, they'd need an hour and a half because that would be 3 halves. which equals an hour and 30 minutes. So that one's just a reasoning one. You got to think about how much can they do per unit. Two functions are shown below. Find where f of x equals g of x. I would do this one in Desmos, plot them, find the intersections. I'll show you that one later. Factoring. Okay, first thing I want to do is look for GCF. Based on the answer choices alone, I know 3 is a GCF, so I'm going to be pulling out a 3. I also see that both of these have x's, so I now know that 3x is GCF, ruling out this answer choice and this answer choice. When I factor out that 3x, I get 16x squared minus 81y squared. When I'm factoring this, okay, this is difference of two squares, so I know I'm going to get two of the same thing, 1 plus, 1 minus. So it'd be 4x minus 9y, 4x plus 9y. So that would be D. Throw out there that if I go ahead and rule out A and B as answer choices, if I'm not sure, I can multiply C and D to check and see which one matches. Also, go ahead and I'll mention this in the other video. I'll talk about how you can use Desmos to show this one. The only issue is having this y squared in here, and I'll see what happens when we talk about it. Number 12. We have a leading coefficient of 1 and has 3 distinct zeros. So if I'm doing this algebraically, I'm doing it this way. I'm saying, okay, I got to have a factor that's x plus 1, x minus 2, and x minus 4. And I need to multiply those to get my answer. One thing, it says it has exactly 3 distinct zeros, which means it's got to be an x cubed function. C and D are out. Now I'm stuck between A and B. You could obviously do this on Desmos and graph and check, but I'm going to show you real quick how to do it by hand. First thing I would do is multiply these two. When I multiply that, I get x squared minus x minus 2. Then I'll multiply these two together. I'll probably go ahead and use the area model because it's getting more complex. X minus 4, x squared minus x minus 2. So it'd be x cubed minus x squared minus 2x minus 4x squared plus 4x plus 8. I'm already seeing that plus 8 is my bottom answer. It's got to be A. When I combine my like terms, I got negative x squared and positive 2x. So yeah, double checking on that. Okay, if f of x equals k parentheses x minus 2 to the 4th, where k is positive, what is the effect on the graph? What they're calling k here is really what we call our a, and we know that this value in front of the function either stretches or compresses vertically. It says k is positive. It could be, so we know that it's c because it's stretched vertically or compressed vertically. All right, 14. I'll do this one by hand. If I want 3h of 2, all right, I know I'm going to look at this function. I know h of 2 is going to be this bottom part. So that would be 3 times, I'm going to plug 2 in for my x. So that'd be 4 times 2 plus 1, which would be 3 times, and this is finding 3h of 2 right here. 3 times 9, which is 27. So the first part is 27 plus 4g1. I know I'm going to look at this part. So that would be 4. G of 1 would be 1 squared plus 2. That'd be 4 times 3, which is 12. 12 plus 27 is 39. You could also check this one on Desmos by just using a table. Okay, number 15. This one's very similar to the last one. So h of negative 4, that means I'm going to plug it in this one. So if I do negative 1/2 times negative 4 minus 15, this gives me 2 minus 15, which is negative 13. So this part is negative 13. Plus 3 times something. We'll find out what h of negative 2 is. h of negative 2 is also going to be plugged into the top equation because negative 2 is less than or equal to negative 4. No, negative 2 is greater than. So I'm going to plug it into the bottom equation. So that would be 20 minus 3 times negative 2 squared. So that'd be 20 minus 3 times 4, or 20 minus 12, which is 8. So 3 times 8, so this would be negative 13 plus 3 times 8 is 24. 24 minus 13 is 11. So that would be 11. Okay, this one where it's increasing and decreasing and such, positive and negative. So I'm going to highlight just to talk about it. So increasing, this part's increasing, and this part's increasing. So I'm increasing from negative infinity to 3, negative 2.5. And from 0 to infinity, the way I'm looking at this. I need to look at these intervals that I've got. So let me keep going here. I'm decreasing on this curve. And that would be from like what? Negative 2 to 0. Interesting the way these are written. Let me real quick also point out that this would be a positive section of the graph, and this would be a positive section of the graph. And these parts would be negative sections of the graph. So let me look at these intervals here. From negative 4, I'm going to start with this interval, negative 4 to negative 1. Negative 4 to negative 1. That's clearly a positive interval. You see how all that between there is blue? So that's your positive. So this one would go negative 4, negative 1. That's your positive interval. The next one, we'll look at this one from negative 2 to 0. So from negative 2 to 0. In between those points, you guys can see that's where the red is. The red was our decreasing. So this would be from negative 2 to 0. Increasing, let's see here, looks like it from 0 to 2. So from 0 to 2. So that would be, let me erase these. That would be, there's my 0 line, there's my 2 line. In between there, I could see that as increasing and being negative. So I'm going to look at my last one as well. 0 to 4. So from 0 all the way to 4, that whole part, so everywhere in here is increasing. So that's going to be my increasing, which means that my 0 to 2 is negative. So I would just look at these intervals very carefully. This is actually a very tricky problem. And look and see, it can only fit one thing. So make sure you're matching them properly. This one's a tough one. All right, a function is shown. What is the distance to the nearest hundredth value of a unit between the two zeros that are closest to each other? I will do this one on Desmos. Which function does not have the set of all real numbers in its domain? Key thing here, guys, exponential functions have all real for a domain. So this one can't be an answer, can't be the right answer. This one, we know this has a vertical asymptote at x equals negative 3. That means that we do not have the set of all real numbers in the domain. The domain would be all real numbers except negative 3. So this would be our answer. Absolute value are all real numbers. Cosine, all real numbers. Number 19. I'll show you how to do it by hand. But since this is a calculator active, please just plug in the answers and check. Right now it's an exponential function written as b to the e equals a. We can convert that to a log. log base b of a equals e. So that would be a log base 9 of 48 equals negative 3x plus 2. This part can go in the calculator, and give me a second because I don't have a calculator in front of me and I need to find out what this is. So log, give me a second. There we go. All right, log base 9 of 48 is, this is 1.76, which is equal to negative 3x plus 2. I'll subtract my 2. And then divide by negative 3. And that gives me 0.079 for x, which is going to be this one, which you could have figured out just by plugging in. You can also do this one in Desmos. I'll show it a little faster. All right, the diagram below shows an angle theta graphed at the xy coordinate 0, 0, where the x coordinate of m is negative 1/2. Key thing here, x coordinate, when we're talking about radians, right? I see radians, I see radii, I see unit circle, theta measured in radians. Remember that sine of theta is equal to your y value. Cosine theta is equal to your x value. So if my x coordinate is negative 1, that means negative 1 is negative 1/2. Negative 1/2 is equal to cosine theta. So the question is, what's theta? Well, I can use an inverse to solve. So one option is do the inverse of 1/2. That'll give me theta. The other option is plug in A, B, C, D into cosine theta, right? And check them off and see what you get. Okay. What I end up getting on this one is not A. So I checked A and I typed it in as cosine 4.712 and I got basically 0 pretty much. 4.189, I got negative 1/2. So that's going to be our guy right there. I'm just going to tell you what these other values came out to be just to show you. 3.927, that gave me negative 0.707. And 3.665, that gave me negative 0.866. So B has to be your answer. Yeah. Ooh. All right. Do this one by hand, but I would also just check it on Desmos. Here we go. We've got a period of 6. So the period is 6, which means 6 has to equal 2 pi over b. So 6b equals 2 pi, which means that b has to be 2 pi over 6, or that simplifies to pi over 3. So there's my b value. A minimum value of 2. Okay, a minimum value of 2. So if my minimum is 2, okay, I know that when I get over here to 6, it says sine, so I'm starting at the midline. I would actually, even though I've gone ahead and shown you how to find your b value, I would do the rest of this on Desmos. So I'll revisit this one on the thing, but note that we've already solved for the pi over 3. This one I don't know, maybe. Desmos, we'll talk about it then. We can plot 22. Yeah, that one's a difficult one. We can take points and look at them. Okay, this one in a parallelogram, drawing my parallelogram going in the order M, N, P, T. Things to remember is that consecutive angles, so like M and N or M and T, those two, they add up to 180. Or these two, they add up to 180. Okay, so M and N, they have to add up to 180. So 6x plus 10 plus 5x plus 10.5 has to be equal to 180. Go ahead and solve that. I'll let you finish solving it. Another thing to note, in case you have a different question, opposite angles have to be congruent. So M and P are actually equal to each other. T and N are actually equal to each other, but consecutive angles add up to 180. So this one, IE is 3x plus 4. EG is 5x minus 6. This is going off of your knowledge that the diagonals bisect each other, which means that this piece and this piece have to be the same. So 3x plus 4 has to equal 5x minus 6. So that would be 2x equals 10, which means x equals 5. Then the question asks, well, how long is FH? Now, this time they were very specific in saying that this was a rectangle, which means that these two diagonals are actually congruent the whole length of them. So I'll find out what each one of these pieces are and add them up together. So 3 times 5 plus 4, that's 19. And 5 times 5 minus 6, that's 19. So 19 plus 19 will give me the whole length, which will be D. Okay, so FH, the whole thing is D. That we had that was like that was this one, right? We just solved it we got 5, and that was A. And they're trying to get you to choose that answer because they know that you're just going to solve something and stop. But the question was, what is the length of FH? So if I don't know it, I'd probably guess that X is 5 and plug it in and see what happens anyway. Just a hint. All right, what is the measure of segment PG? I'm going to first start by pointing out a few things in the diagram and then secondly, labeling the things that I have here. So you'll notice that these angles have been split in half, okay? That is because these are angle bisectors and they are cutting the angles in half. When those angle bisectors happen, here's the thing. There is a circle that can be drawn. Remember when we talked about that? This is one of those problems where if you come across it, we're going to do our best. There's a circle that can be drawn in the middle. Okay, and what we know is that that circle is an inscribed circle. It's an in-center. The thing we need to know is if that's the case, every single one of these is just a radius, and they're all congruent. So I'm going to kind of look at the pictures that the things they gave me, and see what can be set equal. So GH is x plus 3. PG, so this whole thing here, I'm not going to mark it yet because I don't know if I'll need it. PG is that, and GJ, that's another radius, is 2x minus 1. So the first thing I'm going to do is I'm going to do 2x minus 1 equals x plus 3 and solve. That's going to give me x equals 4. And then it says find PG. Well, I have an expression for PG. That'd be 4 times 4 plus 1, which is 17. One key thing on these problems, and you'll notice it on the other geometry, notice how they like put whatever x ends up being in an answer choice. Note that if they are not asking you for x, it's not going to be that answer, but they might have helped you a lot in that question by just looking at the answer choices. You can say, oh, I don't know what it is. I'm just going to plug in one of these answer choices, usually the smallest one, in for what I know an expression that exists for something. So use some context clues and stuff like that. The other Okie dokie. This one, number 26, definitely a Desmos question. Let's talk about number 27. David plans to cover the floor of his own room with new material. The floor is an isosceles trapezoid, because that's kind of like my classroom. It's a messed up trapezoid, whose bases are 16 feet and 26 feet, and whose sides are 13 feet. Each piece of new material has an area of 2.5 square feet. Okay. We want to know how many pieces of new material we're going to need to cover this up. So that means that we need to find an area, which means we need a height of this here trapezoid. Couple things. I'm going to kind of divide these things up and give you some ideas. Area of a trapezoid. Area equals 1/2 base 1 plus base 2 times height. Okay. Notice the area always involves bases and height multiplied together. Sometimes it has 1/2, sometimes it doesn't. This might be a formula you might want to commit to memory. Let's start annotating. If this is 16, this has to be 16 the way I've drawn this kind of rectangle in here, which means that there's 10 left over, and since it's isosceles, it's got to be the same on both sides. So those have to be 5. 5 and 5 on those little right triangles. So if I want to find the height, which is here or here, I need to use Pythagorean theorem on this little right triangle here. So 13 squared minus 5 squared equals the height squared. You're going to get 12. So the area, I'm going to use my area formula now, is 1/2 12, which is height, times the two bases added together, which are 16 plus 26. That gives me 1/2 times 12 is 6. 6 times 42 is 252. Notice, this is not the answer. This is the area. But the answer showed up in the answer choices. Hint, hint, wink, wink. Another problem like that. So if I take 252 and figure out how many of these pieces fit in there, if they're each 2.5, I divide those. 252 divided by 2.5. Hey Siri, what's 252 divided by 2.5?
252 divided by 2.5 is 100.8.
So that'd be the 101 there that we're looking for. Okie dokie then. Number 28. Which was most likely to produce a random sample of 5 students from a school club? Select 5 club members who have brown hair. Interesting choice. Select the 5 club members who have raised the most funds for the club. Select 5 club members from a hat containing names of all members. Bam! There it is. Systematic random sampling. Every time. Okay. This one we talked about together. Key things here is use this formula. You literally just need to plug it in. And then remember that the margin of error always decreases if you increase the sample size. I'm going to let you look at these 22 answer choices. The solutions at the bottom. This one's the same way. I don't even want to go over them because we already talked about them in class. 21. Okay. I'll take a minute just to have these so that you can look at the answers and check them for yourself. So I'm just going to continue talking while you're doing that. Feel free to pause the video. I am now going to go to the next slide. A couple things that are interesting while you're looking at this. DOK, that means depth of knowledge. So if you see a 2, that means that they're calling it a more difficult question. If you see a 1, that means it's an easier question. These are the standards they're aligned to. Here's your correct answers. It'll tell you the question type, whether it's multiple choice or gridded response. Okay, go on to the next one. You're doing that. Here's your other one. So depth of knowledge again, standard, correct answer. The ones that say online only, I'm pretty sure I've given you a solution or we'll discuss it in the other video. You can pause. You can chat. all that good stuff. I'm curious real quick. They said 21 and 22 were the most difficult depth of knowledge questions. I'm going to go back and look at those real quick. Wow. Going back here. Feel free to pause. Feel free to check your word. Okay. I will submit a Desmos one. Probably not tonight, but tomorrow.